to what we are doing today. So as we get to the end of analytical geometry, let's just take a quick look at some of the main ideas. So we definitely covered things like gradient. We covered things like midpoint formula. We've covered things like distance formula, the gradient formula, and then the last two lessons, we were kind of talking about perpendicular lines, parallel lines, and then we spoke about this thing called the angle of inclination. So that kind of the angle that a line makes with the positive x-axis. As we start today, let's start with this question. So I want you to look at this question. It says the lines A and B are perpendicular, and it says the gradient of the line A, which I will make yellow, it says the gradient of that line is minus 3/4. I want to know what is the gradient of, let's say, the green line. What is the gradient of the green line? Who can tell me in the chat? So we know that when lines are perpendicular, their gradients are just negative reciprocals of each other. Or the other way we said it is if two lines are perpendicular, they will always multiply to -1. Okay, so essentially that is it. Okay, well now I want you to find me the equation of the green line. So you know what the gradient is. The gradient is 4/3. What is the full equation of the green line? What is the full equation of the green line? If we look at the drawing, what do we see about the green line? I think that it's actually the y-intercept of the green line is 5. And so we could sub a point in. Really, this is such a lovely question that the equation of the green line will be that. Okay, now I want to know next, because I'm upgrading this question, what is this blue dot angle over there? So I want to know what is the size of that angle over there. And maybe if you're feeling generous, you can put something in the chat to help out your fellow students as to how one might begin finding that blue dot over there. What formula or idea could I possibly use? Yep, thank you, CM Tanda, for being so generous to your classmates. CM Tanda suggested that in the previous lesson, we had a formula that said the tan of theta equals m can be used to find the angle of inclination of a straight line. So I want you to find me what that blue dot is, or the angle of inclination there. What is that angle of inclination? So we know that the gradient is 4/3. So what is my angle of inclination going to be? Thank you, Sange and Ronnie. Anybody else get 53.13? That's looking pretty good to me. And I can see over here, this is an acute angle. And so that makes a lot of sense to me. Okay, I'm feeling confident about that. Now, the next one, I want you to find me the size of the green angle which is the angle of inclination of the red line. This has got a little bit of a twist, but let's let you fly solo first and then see what you get, and then we'll talk about it. So what is the size of the green line over here? So first of all, we're going to have to make minus 3 over 4 equal to the tan of theta. And then we're going to find theta, but what's rather strange is going to happen. Okay, you guys are too clever for me. So what you first get is you get minus 36.87. And what that is this angle over here. But all you need to do to get the proper angle of inclination, and a lot of people are doing this already, is you take that negative 36.87 and you add 180 to it. And if you add 180 to it, you get 143.13, which makes a lot more sense because you can see the size of this big green angle is an obtuse angle over there. Give me a score out of 10 as to how well you understood the first example today, because that was mainly me going over what happened in the last lesson, but I just wanted to check first. So give me a score out of 10. 0 is no understanding. 10 is perfect. 5 is sort of, but still needs to improve. Let me know. Okay, the voting really helps me get a feel for what speed I need to go at in the class. Okay, well, let's start with this one over here. So it says you are given the vertices of a triangle, and the vertices are the following. Now, if you want, you can do a little sketch drawing just to help you. It doesn't have to be to scale, but it can just be to sort of give you a sense of what's going on. But actually, in this case, I'm not going to do it yet until I kind of know I need it. So it says, use the distance formula to determine the type of triangle. So since I have 3 points, I know the one side is AN, the other one is going to be AR, and the other one, AN, AR, and then I suppose NR, are going to be the 3 sides, and it says I have to use the distance formula. So the distance formula always has this structure that looks like this. So find me the length of AN just to get started. Find me the length of AN. If you've forgotten how the distance formula works, it works like that. But find me the length of AN, and it's just going to basically be the square root of some big number. So tell me what you get for AN. And that's the distance AN. Okay. So AN would be -1 minus 8. No, sorry, let me start with the x's. -2 minus 8, so that's going to be 6. And then -1 minus 9, so that's going to be -10. So when I actually get an answer, that is going to be 36 plus 100, which is going to basically be the square root of 136. Now, if you put that in your calculator, and it might give you like a 2 root something, but it'll be equivalent to square root 136. What did you guys get for AN? So 11.66 in decimal form. And that makes sense because the square root of 144 is 12. So the square root of 136 will be close to 12. Okay. Let's find me the distance between those points. And then once you've saw the distances, I want you to tell me what type of triangle is this. So you need to help me figure out, using these distances that you found, what type of triangle is this? Okay, so I've done the second one. I want to know what type of triangle is this once you found all length of the sides. So what type of triangle is triangle ANR? Give me a word to describe this triangle based on what you have worked out as distances. So, Sange, I completely agree. This must be a scalene triangle because all sides are a different length. If two of the sides were equal, it would be an isosceles triangle. If all the sides were equal, it would be a equilateral triangle. Now, the last part of the question says you have to tell me the perimeter of this entire triangle. So what is the perimeter of the entire triangle? I think all I need to do is take the one distance, or let's go with the roots, because then there's less rounding off. So square root 136 plus square root 261 plus square root 97, which are the three sides. And what do I get for my final answer? So Ronnie has put an answer in there. Do we agree? Who else is getting a perimeter? Siamtanda agrees with Ronnie. 37.67 is what Ronnie got. Did anybody else get that? Let me work this out approximately. It's about 12 for that. It's about 16 for that. So let's say 28. It's about 10 for that. So that would be about 38. So my estimation says that that is approximately correct. All right. So this is a pretty standard test type question. I'm using the distance formula to classify a triangle. Now, let's move on to this question. It says, show that the triangle below is right-angled. Now, there's a quick way and a slow way to do this. I want to know from the class, how could you prove that this is a right-angled triangle? Where would you start? Silicani says, must be right units. Yes. It is not, there was no units given here, but it is the convention to write units, yes, because a perimeter is always a function of units. And so you should write units. Thanks, Silicani. Normally it would be like centimeters or meters or something, but yeah. Okay. What strategies do you guys, have you heard about for proving something is a right angle or perpendicular? Okay, Simtanda, I'm with you all the way. Anybody else? So I think if I can show that the gradient, and if I look at the shape, this one looks, I mean, I haven't proved it, but I suspect this one is the one I want to look at. So if I look at the gradient of PQ and I look at the gradient of QR, what I'm hoping is that there will be negative reciprocals or will multiply to -1, and then I will know that this is the right angle. So find me the gradient of PQ, find me the gradient of QR, and then let's see what we can prove. I'll give them color codes just so we can, we'll call that one the green line. And we'll call this one the yellow line. What is the gradient of each of these? So if you've forgotten what the gradient formula is, it's just going to be that. So let's do the green one. 3 minus 1 would be 2. Minus 1 is -2. So I get the gradient of -1 for PQ. What about QR? What do you get for QR? Okay, so that is good news. 6 minus 1 over 6 minus 1 is 1. And this is fantastic news because, watch this. If you go -1 times 1, you get -1. So what that means is the gradient of PQ times the gradient of QR equals -1. Therefore, angle, we can call it angle Q or angle PQR must equal 90 degrees. And so we have proved that this is a right angle because of the relationship between the gradients. The other way you could have done it is if you found the length of the red squiggly line and you found the length of the green squiggly line and you found the length of the blue squiggly line using the distance formula. If you showed that the blue one squared is plus the green one squared was equal to, now I've run out of space here, the red one squared using and the conjugate Pythagoras, that can also prove it's 90 degrees, but it takes way longer. And so I really do prefer the gradient method. All right, let's look at a proper test exam type question. So here is it says ABCD is a parallelogram. and it gives you 4 points and then a mystery point H. Let's start. Find the midpoints of AC and BD. So AC, let's make AC yellow. So that's the diagonal. And let's make this the other diagonal. Now, I want you to find me the midpoint of AC and the midpoint of BD, remembering that the midpoint formula is just the following. Okay, off we go. Tell me what you get. What do you guys get for your midpoints? We notice anything interesting about these midpoints? So once you've got them, I'm seeing something quite interesting happen. I don't know if it's happening for you, but 0 plus 2 over 2, and then 2, wait, 0 plus 2 over 2, and then 2 plus minus 2 over 2, which gives me 1, 0. And then for BD, what do you get for BD? I get 2 over 2, which is 1, and I get 0. So what does it mean? I don't know if you, give me a thumbs up if you got the same as me. So these are midpoints, eh? Okay, now what does it mean if two diagonals have common midpoints? Now, basically, there's this point over here. It cuts the yellow bits in half, but it also cuts the green diagonal in half. And so when we have common midpoints, we say that the diagonals cut each other in half. The diagonals are not the same length. You can clearly see the green one is way longer than the yellow, but they cut each other in half. Okay, so let's have a look at what the question says. It's almost time for a break, but it says, what can you deduce from your answers in 2.1 about the diagonals of the parallelogram? Well, they have we'll say here, I'll write it out for you. So diagonals have a common midpoint. So what that means is that the midpoint of the one diagonal is also the midpoint of the other. Therefore, the diagonals cut each other in half, or the fancy word we say is bisect each other. So they cut each other in half, and that's why you'll see the green one is cut into two halves, the yellow one is cut into two halves, and we say the diagonals bisect each other. Okay, so we have done that one. We're going to come back in a moment after the break and carry on with this question, but I think what we need is a bit of an exercise break. So join me in standing up, because I know it's been a long day, and I know a lot of you are starting to get tired. And the only way that I found to help students get out of that is with moving around. There is very few things. You can either give them a fright, which is hard to do over the internet. In class, it's a bit easier, but it's not always the best. And you do some exercise. That's how you can get adrenaline pumping. Okay, so let's start with jumping jacks today. Let's just be crazy. Let's just go for it. Let's do 15 jumping jacks. So make sure that your space around you is clear. And we are going to go 15 in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, okay, I can feel my heart rate is up, which is good. Okay, while our heart rate is coming back down, let's just do some stretching. So let's take our shoulders, our tricep. We're going to do a tricep stretch. And it's going to be like this. And then we're going to switch to the other side. Oh, that feels good. Especially if your shoulders have been hunching down, then it stretches them out. Oh, nicely. And then let's just do a quick little shake of our arms. Get them nice and loose, like they're a sour worm or like some sort of jelly sweet. Shake this arm. If you're resisting, it means you're tense, which means you need to relax. Stretch out your legs, shake them out. Get nice and loose. Shake everything out if you can. And shake this out. Oh, I like this one. There we go. Shake that out. It feels so good. Yeah. And then let us do the one where we put our arms out. And all we're going to do is gently rotate from one side to the other. And as you're getting more relaxed, you will find that your body will let you go further. Okay, and then last one, let's roll the shoulders back. And then let's roll the shoulders forward. And then one more shake. Shake out the arms. Shake out these arms. Shake out the legs. And tell me in the chat if you feel alive, if you feel like your concentration has been reset a little bit. Just to check if your concentration is really working, let's see if you can solve my brain test. So you need to figure out what is a clock times a soccer ball minus a fan. Not like a football fan, but like a air blowing fan. Over to you guys. So ball is 6. The people have spoken. The ball is 6. I agree. What is a clock? The clock is 3. Agreed. The clock is 3. Now, what about the fans? The fans are a bit more tricky. Aha. What's that 3 for, Amelia? Is it for the clock? So what is one of these going to be? Okay, so the clock is 3. Now, what are the fans going to be? Oh, it turns out Sange says the fans are also 3. So if I go 3 times 3, I get 9, and I take away 3, I get 6. Yep, I agree. Okay, what is the final answer? Using BODMAS, I know that 3 times 6 must happen first, so I get 18, and then 18 minus 3 should give me 15. And so the final answer is 15. Cool. That wasn't too hard, but it wasn't easy either. So I hope you enjoyed that. Okay, let's get back to this old exam question. What I want you to do next is I want you to find the gradients of the diagonals AC and BD. So find me the gradients of the yellow and the green line. And then once you've got them, put them in the chat. So what is the gradient of AC? What is the gradient of BD? So 2, then 0. So I get for the yellow one, I get -2. What do you get for the BD? 3 minus -3, 7 minus -5. That gives me 6/12, which is a half. And that is rather good. What does that tell me about the relationship between the green and the yellow line? Because something interesting has happened, and I want to know if you spotted it. What does it mean if the gradient of the one line is -2/1 and the gradient of the other one is +1/2? It means they must be perpendicular. So we can see here, calculate what is the relationship between the two lines. Well, we know that AC is perpendicular to BD. And the reason it's like that is that the gradient AC times the gradient BD equals -1. So when I multiply -2 by half, I get -1. So these diagonals are not only cutting each other in half, they're cutting each other in half at 90 degrees. Now, when we know this, it says 2.4, hence, give the name of the type of parallelogram it is. So this is not just a normal parallelogram. This is like a superpower parallelogram. And the type of parallelogram it is, if you have diagonals that bisect at 90, so we have diagonals that bisect, not only do they bisect, they bisect at 90. Who has an idea what type of quadrilateral this might be? Maybe you've learned it in class. In the next lesson, I'll go into this in a bit more detail, how to prove different types of quadrilaterals. But before I reveal it, I want to give a chance. It starts with an R. Yes, Dimtanda, it's a rhombus. It's a rhombus. Well done, Sange. Okay, so this is a rhombus, and there's different ways to prove something's a rhombus, the same way there's different ways to prove it's a parallelogram. I always advise the quickest way, and the quickest way to show something's a rhombus is to show that the diagonals bisect, and then they bisect at 90. Okay, let's move on. Find me the equation of the line AB. Now, where is AB? So determine the equation of the line AB. That is just the line up here. So I want you guys to find me the equation of the pink line. Go for it. And just pop your answer in the chat. So gradient of AB seems to be, so can I ask when I use the formula? Okay, no problem. So instead of using, I'll show you now. I'll use that formula this time. So what Ronnie is asking about is, when do I use this formula and when do I use this formula? And the answer is you can use either of them. It doesn't matter. I will show you both, actually, just to show you that it doesn't really matter which one you choose. But what is important is they both have a gradient in the formula. So that would have that one. And then another point on the line. Both of them need another point on the line. So here, I'm going to use the point 0, 2. And I'm going to do the same in this one. So I'm going to go y minus 2 equals 1, x minus 0. Notice how I'm just taking the 0 from here and putting it there, and the green bit from here, and I'm putting it here. It's almost like, well, it is. This is the x1, y1 in the formula. If I then expand it, 1 times x, or x minus 0 is still x. So I get x plus 2. So that would be using the method that you were talking about. In this one, if I take the point 0, 2 and I put it into my equation, I'm going to get that c is 2, and then I'm going to get y equals 1x plus 2, or y equals x plus 2, which is exactly the same thing. So you literally get the same answer. You choose whatever method you like. Okay, let's go on to 2.6. Find the value of k if k is the x-intercept of AB. So you're going to have to use what you just found to find me the value of k. Now, the important thing is it's the x-intercept. So how do you find the x-intercept normally? You make x-intercept, you make y equal to 0. Yeah. So find the x-intercept, make y equal to 0. So let me make y equal to 0. Well, then I must get, yeah, so k must be minus 2. Oh, yes, that makes sense. Look at where k is. It's on the negative side. So I'm quite happy for that to be negative 2. So that wasn't actually so bad. Determine the magnitude of BAC. Now, where is BAC? Ooh, BAC is at the top here. Okay, I'm going to give you a little bit of a hint, because this is a tricky one. Well, give me a thumbs up if you would know how to find the yellow one now. Give me a thumbs down if you wouldn't know how to find the yellow one straight away. I just want to get a feel for how many of you have seen a question like this before. So thumbs up if you would know how to find this. Thumbs down if you wouldn't. I would expect most of you wouldn't have seen a question like this before. That's what I expect, but if you tell me different, I'll listen. But okay, now what makes this so tricky is that it's in a weird place. Okay, I see lots of fingers down, so that's good. That means we're going to learn something new. Could you give me a thumbs up or thumbs down if you would know how to find the red angle, the red dot angle that I just showed you? Okay. So thumbs up if you could find the red angle, and thumbs down if you couldn't find the red angle using what you've learned so far. Okay, so it looks like the red would be no problem. The yellow is a problem. Would you guys be able to find the green angle over here? Thumbs up if you could find that. Thumbs down if you couldn't find the green angle. All right. So I tell you what, everyone, why don't you find me the red one, find the size of the red, find me the size of the green angle, and then I will show you how we can find the yellow one. Okay. So all we're going to do is find the green and the yellow, and then, sorry, the green and the red, and then I will show you how those connect to the yellow. They connect to it perfectly. But first we need to find the size of the red and the green one. Did we find the gradient of AC yet? If we haven't, let's work it out. 2 minus minus 2 would be 4. 0 minus 2. So that was minus 2. So I'm getting the gradient of this as minus 2. Let's check that. 2 minus minus 2 is 4. Yeah. So I want in the chat, I want you to find me the red, and I want you to find me the green, and I want you to put it in the chat for me. So I'm going to give you some time. The formula we're using is m tan theta. And I've made the dots the wrong way around. Sorry, guys, girls. So this should be the green one, and this should be the red one. So minus 2 equals tan theta, but be careful because the first angle you get is going to be the black one over there, and then you still have to work out what the red one is. So you're going to go shift tan minus 2, get an angle, but then you still need to add 180. What are you getting for the red angle? Who's getting what for the red angle? So for the red one, we are getting 116.57, which makes a lot of sense. For the green one, we should be getting 45 degrees. Now the question is, how do we find the yellow angle, which is all the way up here? I'll call it the blue one. Can I make it the blue dot just to make life a bit more exciting, a bit easier to talk about? I think that there is a theorem that describes the relationship between these three angles. Who can remember from grade 8 what theorem deals with these three? We're trying to find, I'm calling it the blue one now, not the yellow one. What theorem is this called? Where the one outside is equal to the sum of the two interior opposites. Yes, it's the exterior angle of a triangle. So we know that the blue one, whatever it is, plus the green one, which is 45, is equal to 116.57, and that would just be exterior angle triangle. So what is my blue / yellow angle going to be? Yeah, Ronnie, let's come to you. What is your question?
So I have a question for the triangle you drew, the one with the blue and the green dots. So I can't see it on the actual
Absolutely. Go for it.
Cartesian plane.
Can
Sir?
you see them?
No, I can't. Is it the one whereby the x-intercept makes the base of the triangle?
Yeah,
I mean
so
the
okay, let me
x-axis.
write these out just so you can see it nice and clearly. So the red one is this one here. So I'm using the gradient of AC to help me. Then over here, that's that green one there. And the one at the very beginning, the thing that they wanted was the angle BAC, and the angle BAC would be this blue thing here. And what I did was I pulled out just the bit about the triangle here to help me see it. Does that help, Ronnie?
Yes, sir. Thank you, sir.
Pleasure. Thanks for the question. So what is the final answer going to be for this mysterious blue angle in this rather tough question? So I think it's just going to be 116.57 minus 45, which is 71.57 degrees. Okay. Now we're almost done with this question. Last question. In AC, determine the equation of the line from C, but perpendicular to AB. So from C, perpendicular to AB. Okay, so what they're saying is that I need to go at a right angle to AB, and I need to go through the point C. Can you guys find the equation of that line? So can you find the equation, and what ideas will I have to use to help me? Ooh. So I have a point on the line, but I don't have the gradient for my blue line. Does anybody have an idea of what thinking I could use to help me? Is there anything hiding in the question that maybe I could help me? So it's actually, even though the midpoint is very tempting, it doesn't say the midpoint. But what I will say is this: do we have the gradient of AB? Have we worked out the gradient of AB earlier on in the question? I think we did. I'll do it again just to make sure, but I'm pretty sure earlier in the question, I worked out that the gradient of AB was 1. And what I think is the question told me that the blue line, which I'm going to make the green line now, is perpendicular. So what is the gradient of the perpendicular line going to be if the yellow one is 1? Okay, it has to be -1. Yes, it has to be -1 because they told me these were perpendicular lines. Okay, now I want you to find me the equation of this green line. I'm pretty confident that that is true, but you still need to find me the value of C. And there's 2 ways you can do that. You can use either method, but I want to see you do that. And then we're going to call it a night for tonight. Now, what point am I going to use? I'm going to use the point 2 minus 2. So what is C going to be? Have I done this right? 2 minus 2 minus 2 plus 2. Oh, I'm getting an interesting answer, but I think it's correct. So that's -2 plus 2. What that is saying, and that's a bit weird, is that C is 0, which means the equation of the line is minus 1x plus 0. Now, I don't think this is drawn to scale, but what that's saying is that the line goes, oh, yeah, it doesn't have to go through the midpoint. So all that has to happen, if I look at this does actually look more perpendicular. So it is actually going through the origin, this blue line. And so the final equation of the line is minus 1x plus 0. All right, so that was a full-on exam type question from a past paper. In the next lesson, we're going to do more like this, but we're also going to talk about how do we prove something is a parallelogram. So we had a bit of a preview of that today. We're going to look at whether or not there are common midpoints. We'll look at the midpoints of the diagonal. We'll also look at how do we prove something is a rhombus, which you also had a bit of a preview for that. We'll look at questions like this. How do you show this, and how do you identify the quadrilateral? We'll probably also look at some intersection points, and then we will finish off basically analytical geometry